Hey everyone! Welcome to ZoomInData. Let's learn the KQL concepts, and this is episode 1. Today we're kicking things off by answering the big question: why did Microsoft even create KQL in the first place? This stuff is gold for interviews, especially in Azure, Sentinel, or data roles herein. Let's dive in. Alright, quick roadmap for today. We're going to look at how data exploded in the 2010s and 2020s, why classic relational databases started struggling big time with modern workloads, what telemetry and log data actually mean in practice, how KQL was born inside Microsoft to fix exactly these issues, the smart design choices they made, and finally why understanding this, why, will make you stand out in interviews. Sound good? Let's start with the explosion part. Picture this. Back in 2010, the world was creating around 2 zettabytes of data per year. Fast forward to 2020 and we're already at over 64 zettabytes, and it's only accelerating. That's not just more spreadsheets, that's trillions of tiny events every single day. IoT sensors sending temperature readings, mobile apps logging every tap, servers spitting out performance metrics, security tools capturing login attempts. This is high volume, high speed, constantly arriving data. Traditional tools just weren't ready for that kind of fire hose. So why do SQL Server, Oracle, or Postgres start sweating when you throw telemetry at them? They're built for OLTP, online transaction processing. Think updating bank balances, inserting customer orders, strong ACID guarantees. But for logs and metrics, row-based storage means scanning billions of rows is painfully slow. Schemas are rigid, so evolving JSON logs become a nightmare. Full text search is expensive, time series features are bolted on, and scaling to petabytes costs a fortune. It's like using a sports car to haul cargo. Wrong tool for the job. Let's talk telemetry. It's basically the vital signs of your systems. Every click in an app, every error on a server, every heartbeat from an IoT device, every security event. It's append only. You don't update old events, you just keep adding new ones. Almost always time-stamped, often high cardinality, like unique user IDs or device names, and usually immutable. It's not about transactions, it's about observing what's happening right now or over time. Okay, now let's zoom in on logs specifically. They're even tougher than plain telemetry in many ways. Logs are usually semi-structured or completely unstructured. You get a mix of free-form text messages, embedded JSON objects, timestamps, severity levels, and random key-value pairs. And the format can change over time as teams update logging libraries or add new fields. At enterprise scale, you're talking gigabytes, sometimes terabytes, of logs pouring in every minute. That's insane velocity. You can't afford to wait minutes for a query. Analysts and security teams need answers in seconds. What do people actually need to do with logs? They want to search any word or phrase instantly, like find every occurrence of connection refused or high latency. They need to slice by time windows, show me errors from the last 7 days, grouped by hour. They want to spot anomalies, sudden spikes in error rates or unusual patterns. And for compliance or post-incident reviews, you have to keep logs for months or even years without breaking the bank on storage. Traditional databases choke on all of this. Full text search is slow and expensive. Time grouping requires extra indexing, and storing petabytes of semi-structured text gets outrageously costly. This is exactly why Microsoft needed something new, a system built from the ground up for log chaos at scale. So where did KQL come from? Back in the early 2010s, Microsoft was drowning in their own data. Bing search logs, Azure infrastructure metrics, Office 365 activity streams, all at massive scale. They needed something that could query petabytes in sub-seconds, search any text instantly, and handle time windows natively. That's when they built an internal tool called Kusto, fun fact, named after Jacques Cousteau, the famous ocean explorer, because they saw data as an endless ocean to explore. Kusto delivered exactly what they needed: blazing speed, easy text search, and time smarts like relative windows and binning. By 2018-2019, Microsoft realized this wasn't just useful internally, it could help everyone. So they released it publicly as Azure Data Explorer, or ADX. And today, the same KQL engine powers almost every Azure monitoring and security product: log analytics in Azure Monitor, hunting and analytics in Microsoft Sentinel, real-time intelligence in Microsoft Fabric. KQL wasn't created as a general-purpose language. It was purpose-built from real pain at Microsoft scale, and that's why it's so good at what it does. Now let's talk about what makes KQL tick at the design level. These aren't random features. Every one is a deliberate choice for telemetry and logs. First, columnar storage. Instead of storing entire rows together, KQL stores each column separately. That means when you ask for the sum of one field across billions of rows, it only reads that single column. Huge speed boost and amazing compression because repeated values, like the same error code, compress really well. The pipe syntax, that vertical bar, lets you chain operations naturally. Filter, then summarize, then sort. It's like thinking out loud. Take the data, throw away what I don't want, group it, count it. Super readable for analysts. Append-only design. No need to update or delete old records. Logs and telemetry are immutable. Once an event happens, it stays. That simplifies everything and fits the data perfectly. Time intelligence is baked in. Ago, 7D, for relative windows, bin, for grouping by hour per day, date-time math, no extra libraries or workarounds. They even use approximate algorithms like hyperlog for distinct counts. You trade a tiny error margin for 100x faster queries, which is fine when you're looking at trends, not counting pennies. And dynamic types mean you can ingest JSON logs without defining every field up front. The schema evolves with the data. All these choices were made because KQL was built for one job: making sense of massive, fast-moving, semi-structured event data as quickly and cheaply as possible. So how does KQL really differ from the SQL we're all used to? Classic SQL is declarative. You write select, from, where, group by and tell the database, this is what I want, and the optimizer figures out the best way to get it. It's fantastic for normalized data with lots of joins, transactions, and updates. KQL is pipeline-oriented. You use pipes to say, start with this table, filter it this way, summarize that way, sort it. You have more explicit control over the steps, and it's very natural for chaining transformations. SQL is usually row-oriented and shines in OLTP. KQL is columnar and dominates OLAP-style workloads, especially high-volume, immutable events with heavy text search and time-based aggregations. At telemetry scale, billions of rows, petabytes of logs, KQL is frequently 10 to 100 times faster and much cheaper because it avoids scanning unnecessary data and compresses so well. That's why interviewers often ask, Why not just use SQL for logs and telemetry? The answer is right here. Different philosophy, different strengths, and for KQL's use case, the pipeline plus columnar combo wins big time. This is where all this theory pays off in real interviews, especially for roles like Azure Data Engineer, Microsoft Sentinel Analyst, Fabric Real-Time Intelligence Engineer, or any Azure Monitoring, Analytics position. Interviewers love these kinds of questions. Why was KQL created? How is it different from SQL when analyzing logs? Describe a real scenario where a traditional RDBMS would struggle but Azure Data Explorer shines. What characteristics of telemetry data make KQL the right tool? They aren't testing if you can write a perfect query on the spot. They're testing if you understand the why behind the language. If you can explain columnar versus row, pipeline versus declarative, append-only mindset, and the scale problems KQL solves, you'll stand out every time. Conceptual depth wins interviews more than syntax tricks. To wrap up episode 1, today's world runs on telemetry and log data, huge volumes, real-time arrival, semi-structured chaos. Traditional relational databases were designed for transactions and updates, not for this kind of scale and style of analysis. KQL, and Azure Data Explorer, was created specifically to solve those exact problems with smart, intentional design, columnar for speed and compression, pipes for readability, append only for immutability, built-in time functions, and more. The most important thing you take away today is the why, not just how to write a query, but why KQL exists and why it's better for certain jobs. Get that foundation solid, and the rest of the series, and your interviews, will be much easier. That's it for episode 1. Hope you enjoyed the deep dive into why KQL exists. Next up in episode 2, declarative versus pipeline thinking, we'll explore the core philosophical difference between traditional SQL and KQL, and why that matters for how you think about queries. For homework, and this is great interview practice, pause the video and try answering these out loud. Explain why we can't realistically use SQL Server, or similar RDBMS, for petabyte-scale log search. Think of 2 real-world examples of telemetry data, maybe from your projects, work, or even daily life like fitness trackers or app usage. Quick research. When did Azure Data Explorer become generally available? Say your answers aloud. It really helps cement the concepts for interviews. If this was helpful, hit the like button, subscribe for the rest of the series, and drop a comment with your biggest takeaway from today. Thanks for watching. See you in episode 2. Stay conceptual, stay ahead. Thank you so much for watching my channel ZoomInData. It means a lot that you're here learning KQL concepts with me. If this episode helped you, please hit the like button, subscribe so you don't miss episode 2, and drop a comment with your biggest takeaway from today. See you in the next one. Stay curious, stay conceptual. Bye for now.